All right, we're looking at 5B part, or sorry, 6B part 2. 6B is all about coordinate proofs, remember? So what is actually a coordinate proof? A coordinate proof is just a proof that uses slope, midpoint, and distance to prove theories on a coordinate plane. What are we going to be proving? What we're going to be proving is if you're given a shape, such as a triangle, what type of triangle is it? Right? We prove that it's this type of triangle. Same thing with a quadrilateral. A quadrilateral is anything that has 4 sides. So if you're given 4 points, right, that make up a 4-sided figure, it could ask you what type of quadrilateral is it. Okay? So we're going to use what we know about slope, midpoint, and distance to prove these. Okay? So how do I prove something is a certain type of triangle? Well, triangles we will all use the distance formula. Okay? Triangles, there's 3 types of triangles we're going to look at. A scalene triangle has all 3 sides of a different length. An isosceles triangle has 2 sides that are the same length and 1 that's different. An equilateral triangle has all 3 sides the same length. Okay? So for a triangle, we'll find the length of all the sides, and then we have to see, are they the same, are they different, and just pick which type of triangle it is. All right. Quadrilaterals are a little bit trickier because there's a lot more different types of them. Oops, all right. So for a quadrilateral, you have a trapezoid, a parallelogram, a rhombus, a rectangle, or a square. Okay. For quadrilaterals, we always start by looking at, do they have parallel sides, right, or not parallel sides? So a trapezoid is a quadrilateral with only 1 set of parallel sides. 1 set of opposite sides parallel. So it's something that looks like this, right? One set of sides across from each other will be parallel, right? The other sides don't have to be parallel, right? I can see something like this. These 2 sides are not parallel. These sides are parallel. That's a trapezoid. A parallelogram has 2 sets of opposite sides parallel. Something like this. These sides are parallel to each other, and these sides are parallel to each other. A rhombus is the same as a parallelogram, so 2 sets of opposite sides with 4 sides of equal length. Okay? So not only are all of these parallel, all 4 of these sides are also congruent. So now looking at a rhombus, now we're not only bringing in parallel sides, but also distance formula. For a rectangle is a parallelogram, so the sides are still parallel, right? This side is parallel to this side parallel to this side, but it also has right angles. So these 2 sides are perpendicular, and these 2 sides are perpendicular. Okay? So now we have to start looking at perpendicular too. And then a square is a rectangle with 4 sides of equal length. Right? So a square, right, again, the sides across are parallel, these sides are perpendicular, and now these sides are congruent. Okay? So for quadrilaterals, there's lots of things we have to check. We have to check, are the opposite sides parallel? Are the sides equal? And are the adjacent sides, or the sides that are next to each other, perpendicular? To help us out with this, tomorrow I will be passing out this formula sheet that you see here. So it's just a sheet that will tell you exactly like what question to answer first. Right? So the first thing you're going to see is parallel sides, right? And you can kind of go, if there's 1, it's going to be a trapezoid. If there's 2, then I have to ask myself this question. Are they perpendicular? Yes, no. And then ask yourself, are they all the same length? Okay, so it kind of will just help you get used to what questions you have to answer as you're going through these problems, okay, and what questions you have to ask yourself. You will not be able to use this on any tests or quizzes, so it is really just to help you while you practice. So let's look at some example problems. So example 1, classify the triangle as scalene, isosceles, or equilateral. Provide reasoning and math to back up your answer. So what I'm going to do is I'm going to find the distance of each side, or the length. Just go like straight up and straight over, or straight down and straight over. Okay. This is a triangle with a length of 2 and then 1 each. Okay? So then I'm trying to find this side here. So 2 squared plus 8 squared equals b squared. That's 4 plus 64 equals b squared. So 68 equals b squared. So c equals the square root of 68. Okay? And I don't even have to put it in my calculator. I don't even really need to figure out what that is. Square root of 68 will give us enough information. Okay? So let's look at our next side. Our next part. Right? So I'm going to look at this side now. Straight down, straight over. Right? This is a triangle with 3, and then 1, 2, 3, 4, 5, 6, and then 8. Okay? So now I have 3 squared plus 6 squared equals b squared. 3 squared is 9 plus 36 equals b squared. Adding those together, I get 45 equals b squared. Take the square root of both sides. The square root of 45 equals b. Okay? And again, I don't even really need to figure out the square root of 45. If I have the square root of 68 and I have the square root of 45, I know just from looking at these that those aren't going to be equal. And that's really all I care about. So don't even need a calculator. All right, now we still have to figure out our last side. We do have to figure out all 3. So now I'm going to find this triangle. This is a 4 by 5. 4 by 5. And we're looking for c again. So I'll do it down here. 4 squared plus 5 squared equals c squared. So that's 16 plus 25 equals c squared. When I add those together, I get 41. Take the square root, take the square root. So c equals 40, the square root of 41. So again, I don't even have to use a calculator. None of these are the same number inside my square root. That means none of these sides are equal. Going back up to our definitions, a triangle that has no sides equal is scalene. Okay? So I can say this is a scalene triangle. Scalene triangle. If 2 of the sides were the same and 1 was different, it would be an isosceles triangle. If all 3 sides were the same, then it would be an equilateral triangle. All right, let's turn to the next page. Example 2 says graph the quadrilateral with the coordinates p, -1, 4, q, 2, 6, r, 5, 4, and s, 2, 2. Then determine the most precise name of that quadrilateral. Sorry, that's a really hard word for me to say. Right, reasoning and math to back up your answer. All right, so let's start with the first part. Let's graph this quadrilateral. So -1, 4, 1, 4. That's P. Q is 2, 6. R is 5, 4. And S is 2, 2. So let's look at our first question that we need to ask ourselves. Our first question is, are there one set of parallel sides or 2 sets of parallel sides? Okay, so I'm going to find the slope of all of these to figure out if the sides are parallel. Remember, parallel lines have on the same slope. Okay? So let's start with PQ. So M stands for slope. Slope of PQ equals, it's x2, y2 minus y1, so 6 minus 4 over 2 minus negative 1. 6 minus 4 is 2. 2 minus negative 1, right? And we change this to 2 plus 1, so that's 3. Okay. So I did P to Q, now I'm going to do Q to R. So the slope of QR equals, again, that's 4 minus 6 over 5 minus 2. 4 minus 6 is negative 2. 5 minus 2 is 3. Next step, RS. The slope of RS, that's 2 minus 4 over 2 minus 5. Equals negative 2 over negative 3, which is the same as 2 over 3, right? A negative divided by a negative is a positive. And then the slope of ST equals 4 minus 2 over negative 1 minus 2. That's 2 and negative 3, which is the same as negative 2/3. You can always just pull that negative. If there's only one negative, just pull it out to the front. Okay? So now, I'm asking myself, are there one set of parallel sides or two sets of parallel sides? Okay? So I'm looking for same slopes. So I wrote it here, makes it nice and easy. I have this, these slopes are equal, and these slopes are equal. That's 1, 2 sets of parallel sides. Okay? So going back to our quadrilateral worksheet, right? It would be 2. So I'm going to follow this and go to this question. So now my next question is, are the adjacent sides perpendicular? So now I'm really just looking for perpendicular slopes. Oops, sorry, one thing. And perpendicular slopes, remember, have opposite reciprocal slopes. Okay? So I know these are equal, so I'm going to look between these two sets of lines. Okay, between these two sets of opposite sides that I found. If they're perpendicular, then that question would be yes. If they're not, it's no. So I'm comparing 2/3 and negative 2/3. Right? Well, it's opposite, but it's not reciprocal. So these are not perpendicular. So opposite, but not reciprocal. So they're not perpendicular. Okay, so going back to that chart. Are they perpendicular? No. So now I'm going to ask myself this question. Are all 4 sides the same length? Now I have to do exactly what we did before. Now I have to do my distance formula for all 4 sides. So, looking at PQ first, is a 3 by 2 triangle. Squared plus 3 squared equals c squared. That's 4 plus 9 equals c squared. C squared equals 13. So c equals the square root of 13. Okay. Let's look at our next side. 2 and 3 triangle. With doing this, right, with using that Pythagorean theorem, a lot of times it should be pretty obvious. Well, these two equations are exactly the same. Of course, this is still going to be the same side, right? I don't have to show all that work again. That's silly. All right. Next side, you do still have to show the setup for all of them. Let me be clear with that. You do still have to show the setup for every problem. You don't have to show this work, right? You can kind of just jump from there. Where did that All right, so then I have to do RF. Right, these sides, that's a 2, X to 3. So that's 2 squared plus 3 squared equals c squared. Again, same equation. So c equals the square root of 13. And finally, I have s to t to q by a 3 triangle. So 2 squared plus 3 squared equals c squared. So c equals the square root of 13. So are these all the same length? Yes. Yes, they are. So when I look back at that thing, I went, there's 2 sets of parallel sides. They are not adjacent. And then they are the same length. So that makes it a rhombus. Okay? So this shape is, through all this work, a rhombus. Yay. Okay? So it's really just following those 3 questions along. And that's all we're going to do today. I'll see you guys tomorrow.